Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is distinct absolute of array elements. So in this question, we have an sorted array of size n, and we need to tell that how much count of we need to tell that how much number of distinct absolute values are present in that array. Okay, now basically this type of sorted array that are provided us, and we need to tell that the count, how much number of distinct absolute numbers are present in that array. Okay, so first we are calculating the distinct number that are present in this array. So the distinct numbers are -3, -2, -1, +1, +3, +4, and +5. Okay, now these are the distinct numbers that are present in this array. Okay, now calculating the distinct absolute numbers, and we need to return the count, how many numbers are present in the distinct absolute. Okay, now these are the distinct numbers, and calculating the distinct absolute, for that we are taking the -3's absolute value, that is +3, and we are also initializing count as a 0 here first. So the distinct absolute, minus three's absolute value is +3, so we are adding 3 here, increasing our count by 1. Okay, after that this is done. Now -2's absolute value is +2 +2, so adding this +2 here, increasing our count by 1. Now this is also done. -1's absolute value is again 1, that means 1. Okay, add this one here, increasing our count by 1. Now this is done. Now again 1 appear here, so -1 and 1 absolute value is 1, so these are the same, so we cannot add this into distinct absolute because 1 is already appeared here. Okay, so we cannot get this one into this. Why? Because 1 is already appeared. So now again 3 cannot be get here. Why? Because 3 is again already there. Now 4's turn. 4 can be distinct. 4 is a distinct value, so we are increasing our count. 5's turn. 5 is the distinct absolute, so we are increasing our count as 5. And these are the distinct values are present in this array, and distinct absolute values present in this array, and this is the count of that numbers. Okay, and we need to return this count. So basically for finding the distinct numbers in the any array, the first approach that comes into our mind, that is by using hashmap or hashset. By using that we can get easily the distinct absolute values. So but the question have some properties. This question have some properties. We have two properties for this question. The first one will be the array is in sorted order, and second one will be the space that we can use here to solve this question, that is O1 space. We need to solve this question into O1 space. So because of that, we can't use the hashmap or heap here, hashmap or hashset here. Now for solving this into O1 space, what will be our approach? So we can, for example, our array is looks like this: -3, -2, -1, 0, 1, 2, 3. So this is the leftmost element, rightmost element. So by comparing these two, we need two pointers. First we need two pointers. Now after that, basically we are using pointers here. By using that, we are only traveling onto this array only by one time: I plus plus, I, j minus minus, and so on and so forth. Okay, now we want two pointers here. If we are finding -3's absolute and 3's absolute value is same, so we can get one distinct absolute value, so we can increase our count by 1. Okay, now I plus plus, j minus minus. If multiple numbers of 3 are present in the array, if it is not present in this array, but if it is present in the array, it is present at these positions. Why? Because it is in sorted order. So if the j is pointed to these 3, if j is pointed these 3, okay, these 3, if our j is pointed to these 3, and we got another distinct absolute, it is not the distinct absolute, but we got another distinct absolute. Why? Because we can't, at this point we did not check the which element is present in the distinct absolute. So for for that we also want the previous or next elements variable. Why? If I am at here at this point, if I am at this point, so at this point I want to know about is -3 is already present in this array or not. If it is present, then we want that value for comparing it is present or not. Similarly at this point also, at this point now we are at 5 at the 7th index. So at that time we want the next element count also, next element store also, so we can compare it with this, with the next pointer, and at this point we can compare this with the previous pointer. So it will tell us this element is come already or not, already encounter or not. So basically let's start with the pointer method. Okay, let's start with I is at here, j is at here, and we have the previous pointer. For example, we have previous pointer, next pointer for storing the value of rightmost elements, previous pointer storing the value of leftmost element, and we have the count. Okay, count. Initially it is at 0, and previous point is pointed at somewhere here, that is -infinity, and next point is at somewhere here, that is +infinity. Now let's try to iterate over this array. Now I is at here, j is at this point, and I is at this point. Now we are checking that math of absolute, just checking that math's absolute value of array of I, that is 3. Math dot, in the Java we are checking that math dot apps of array of I, so it gives us math.apps of -3's value, it gives us +3 plus 3 value. Okay, so we are comparing that 3 and 5, our comparison in between these two. So basically in this, at this point we can get 3 into this portion. Why? Because it is in sorted order. Because of it is in sorted order, we can get 3 into this portion as well. So for that purpose, our main priority to check this with these two, -3 with this 3. Why? Because if for that if our distinct, for example our let's distinct absolute contains already 3, our distinct absolute are already contains 3's value, and now we are at here, and if I am at here, so we cannot know about these 3. So basically first we are iterating over it. After that, after the second iteration, you can get this point easily. So let's try to iterate over it. So first I is here, j is here. Now my absolute values of -3 is 3 and absolute value of 5 is 5. So I am giving the priority to the most greatest element in between there. Okay, now why? If the -5 is present in this array, then it will be somewhere at here. So we can check that -5 and 5 is absolute value, and we can increase our count as a distinct absolute. So let's see further. So -5 sorry, 5 is here, so it is a distinct number for now. Why? Because at its right position there is only infinity, so no one is present at its right. Okay, so we can increase our count, and after that first work checking that our first work checking that is this is array of j, is array of j is equals to next, is our array of j is equal to next. If it is equals to next, then we for example we are at this point and we have the 5 at its next, so at this point we are checking that is array of j is equals to next, is array of j is equal to next. So that, so this is, if this condition is true, so we can say that 5 is appear for the second time here, So now our first condition at this point is check the condition here, and now we are checking that with the 5. So is 5 is equal to next? Is array of j is equal to next? At this point, no, 5 is not equal to next. So we can add the 5 here, update the j as a j minus minus. So now again, we got 5 here. Now I is 3 at 3 and j is at plus 5. Again, the condition uh, gives favor to the minus 5. Now at this point, we are checking that is array of j is equal to next? Is array of j is equal to next? Yes, it is equal to next. So because of that, we can't increase our count because the previous distinct absolute number is 5. So update the value of next as a 5, update the j as a j minus minus. Okay, now we are at array of I is at 3 absolute, minus 3 is absolute is 3, array of j is absolute is 4, 4's absolute value is 4. Now again 3 is 4 is greater than 3, 3 is less than 4. Now again we are giving the priority to the 4. Now 4 is checking is array of j is equal to next? Array of j is equal to next? No, it is not equal to next. Because of that, we got another distinct absolute value. First distinct absolute value, distinct absolute is equals to 5. First value is 5. Now we are checking that is the array of j is equal to next? So it is not equal to next. Because of that, we got another distinct value, distinct absolute value. So it is a 4. Update our count as 2. Okay. Now update the next as well as a 4 and update j as a j minus minus. Now at this point, this is a very important point. At this point, we got absolute value of array of I is 3. Absolute value of array of j is again 3. So both are same. Both are equal. So if both values are equal, then we are checking that its previous and its next. First thing, we need to check that its previous value is same, is its next value is same. So it is not same. In this condition, the previous value is minus infinity and its value is minus 3. So it is not same. So because of that, and at this point, at this point, we are checking the its next value. We are checking it with its next. So its next value is 4. So we got another absolute distinct absolute number and increase the count here, update the value of 3 here, update the value of previous as a minus 3 here, update I, update j. Now at this point, 3 is absolute, minus 3 is absolute, 3, 1 is absolute, 1. Now 3 is greater than 1. At this point, 3 is greater than 1. So we are giving the priority to the greatest element in between them. Now we are checking that. At this point, we are checking array of j with next. At this point, we are checking array of I with previous. If it is equal, then we can surely say that this number is repeated. Okay. If this condition is true, then we can surely say that this number is repeated. Now we are checking that array of I, array of I is equal to previous. Yes, it is equal to previous. Because of that, we can't increase our count. Why? Because distinct absolute number already contains 3. Okay, so we are just increasing at this position. We are update our previous as a minus 3, increasing our I here at this position. Now at this position, okay, at this position. So our minus 2 absolute is plus 2. J's value plus 1's absolute is plus 1. So again 2 is greater than 1. Now again we are checking that is array of I is equal to previous. Is 2 equal to minus 2 equal to minus 3? No. Because of that, this condition is not true. We can easily increase our count. We got another one distinct absolute value. Update the value of this update the value of the previous as a minus 2, increase the count of I here. Now at this point, array of i's absolute, that is minus 1's absolute, is 1. Array of j's absolute, that is plus 1's absolute, is 1. So both are equal, so we are just checking the previous value and the next value of both of them. Now the previous value of this point is array of I is equal to previous. No, it is not equal to previous. Because of that, and both condition we want will be, it will be true. So at this point, array of j is equal to next. Is 1 is equal to 3? No, both conditions are true. Because of that, we can say that we got another distinct absolute. Increase our count by 1, increase update our next as a 1, update previous as a -1, update our I at this point, update our j at this point. Now we are traversing over this array. Now again run again one traverser for the better understanding. Again we are try run over this for the better understanding. First we are starting with ij at I is at 0 and j is at this point. Now we have previous point that is set at -infinity, next point that is set at +infinity, and count. And for better understanding, distinct absolute number. Okay, at this, in this portion we are checking is array of j is equal to next. If it is equal to next, then it is a repeated number. If array of j is array of I is equal to previous, if it is equal to previous, then it is also repeated number. So these two conditions we need to check. So let's parse over it. Now I and j, I's absolute is 3, J's absolute is 5. So 5 is a greater element, so we are just checking that with this. So is array of j is equal to next, is 5 equal to infinity? No, because it is not equal to infinity. So we got our first distinct absolute, that is count is 1, update the next as 5, update our j as the j -1. Now again checking that 3 is absolute, -3 is absolute, 3, 5 is absolute, 5. Now we are again checking that is array of j is equal to next, is array of j is equal to next? Yes, it is equal to next, so we can say that it is a repeated number. So because of that, we can't increase our count. Update the value next as this, update the value of j. Now at this point, array of i's absolute, -3's absolute is 3, plus 4's absolute value is 4. At this point again 4 is greater than 3. Because of that, we are checking that is array of j is equal to next, is array of j is equal to next? No, it is not equal to next. Because of that, we got our another distinct absolute value. Because of that, we are increasing our count here. Okay, and adding this number into this next, and j minus at this point. This is a important point. Okay, this is very important point. -3 is absolute, plus 3 is absolute, again plus 3. So these two are same. Now at this point, if the condition, if the both are true, both are equal, then we are checking that these two numbers -3 here, we are checking that with the previous, plus 3 here at this point, and we are checking that with the next point. So is array of I equal to previous? No. Is array of j is equal to next? No. So we got another distinct absolute, add this into this, increase our count by 3. Okay, after that, update our previous and next with -3 plus 3, update the I at here, j at here. Now at this point, -3 is absolute, plus 3, plus 1 is absolute, plus 1. Okay, now 3 is greater element, 3 is the greater element, 3 is greater than 1. Now we are giving the opportunity for 2, 3. Now we are checking is array of I equal to previous, is array of I equal to previous? So -3 is -3 equal to -3? Yes, it is equal to Because of that, we can't increase our distinct absolute. Why? Because 3 is already at that point. So update this 3 minus 3 as this minus 3, update I. Okay, now we are at this point minus 2. So minus 2 absolute value is plus 2, plus 1 absolute value is plus 1. Now again 2 is greater. Now at this point we are checking, is array of I equal to previous? Is minus 2 equal to minus 2? No, it is not equals to. Because of that, we got another distinct absolute, increase the count and update the value into the previous, update the I. Now at this point, minus 1's absolute value is 1, plus 1's absolute value is 1. So we got same values. So at this time, we are checking this with the previous array of j with next. Is array of I minus 1, is minus 1 equal to minus 2? No. Is plus 1 equals to plus 3? No. So these two are true. Because of that, we got another distinct absolute. So this is the 1 and increase the count here. So this is the approach to solve this question. So I recommend you to pause the video here, code by yourself first. If you can't do code by yourself, so again come here. So I assume that you pause the video and code by yourself. Now let's start with the solution here. So this is our ID, Pepcoding Nado's ID. So let's first full screen here. Increasing the. So first thing first, for solving this question, we need 4 pointers. 4 pointers. 1 minute. Pointers. So first pointer is I at first position, that is 0th position. Second point is j. J is placed at last position, that is array dot length minus 1. Now we want previous pointer and next pointer. The previous pointer is placed at integer dot mean value, and the next pointer is placed at integer dot max value. Okay, integer dot max value. Now we want the count is count that is initially 0 first. Now we are running a loop over if I is less than equals to j, or while I is less than equals to j. So the first condition, if both are equal, if both are equal, if I is less than j, that means array of I, if array of I is less than array of j, then we are doing something. And if array of I is greater than array of j, so we need to operate these three conditions. So the first condition is we are taking the absolute value of that array of I. So math dot absolute of array of I, checking that is equal to math dot abs of array of j. If these two are equal, then we are doing something. Now in this condition, else if we are checking that with the math dot array of I is less than math dot absolute of array of j. We are checking that, and the last part is the else part. So in this part, if this is the first part, let's talk with this first part. At this point I and at this point j, 3 and 5. Now at this point we are giving the priority to the 5. So if the greatest element it's present on the right side, then we are checking that if array of j is equal to next, if this condition is true, then we can't increase our count. Why? Because it is a repeated number. For example, our j is placed at here. If this condition is true, so this condition checks that is 5 is equal to 5. So if it is true, then we can't increase our count. So we are checking that here, if our array of j is equal to next, if this is if it is not equal to next, then we are increasing our count by 1. Why we are checking that if it is not equal to? Because if it is equal, then it is a repeated number. If it is not equal, then it is a distinct absolute. Okay, now after that, update that value into next. Okay, and update the value of j. Same work for else part. Just copy this, paste it here, check this with is array of I is not equals to, if array of I is not equal to previous, then increase count. After that, update the previous value with array of I and update the I with I plus plus. Okay, these two conditions are done. Now if we are at this point, and this point, if our I is here and j is here, if 3 is equal to 3 at this position, for example, let's take this position, our I is at this point and j is at this point, at this position 1 is equal to 1. So we are checking that array of I is equal to previous or array of j with next, both conditions. So first let's write code for this. If array of I is not equal to previous and array of j is not equals to next, if these two conditions are true, if these two conditions are true, at this point we have -2 at the previous, and at this point we have +3 as the next. So we are checking that is these two, is array of I is equal to previous, is not equal to previous, is array of I is not equal to previous, and array of j is not equal to next. If it is true, then increase the count. Simple, increase the count at this point. Okay, just at this point increase the count. After coming out of this if condition, we need to update our previous with array of I, next with array of j. After that, update the I and j as well. So this is our code. Let's try to run this code. So it gives 0. So we want to return count here. So let's try to run this code again. So it gives 5. So simple output value is also 5. Let's try to submit it. So all the test cases are passed here. We got the full marks. So first let's try run this code over this array. Let's give me a second. Just give me a second. Okay, let's snap off this code. Let's take this code onto open board. So this is our open board. First we are checking that. Okay, now let's take this code to this part. Okay, now our I and j is at 0. I at 0 and j is at the last point. Previous at -infinity, next at, okay, previous at -infinity, next at +infinity, and the count is initially 0. Okay, now we are in this loop. We are checking that is this absolute value is equal, is 3 and 5 are equal? No. Is 3 is less than 5? Is 3 is less than 5? Yes, it is true. Then we are checking that is array of j is not equal to next. Array of j is not equal to next. Then increase the count, update the value of this point into next, and update the value of j as the j minus 1. Now again, absolute value of I is 3 and absolute value of j is 5. Now again we are checking that conditions, and we are into this if condition. So this if condition is false. Why? Array of j is equal to 5. Because of array of j is equal to 5, we can't increase our count. So after that, update the value of next is this, update the value of j is minus minus. Now again we are at this point. Now at this point, 3 is again less than 4. Again 3 is less than 4. We are checking that is array of j is not equal to next, is 4 is not equal to 5? Yes, it is true. Then we are increasing our count. Okay, after that, update the next, update the j is at here. Now we are checking that is 3 is equal to 3, is 3 is equal to 3, is 3 is equal to 3? Yes, it is 3, it is equal. Then we are checking is array of I is not equal to previous, is 3 is not equal to minus infinity? Yes, it is true. Is array of j is not equal to next, is 3 is not equal to 4? Yes, it is also true. Then increase the count. Okay, after that, update these two values, minus 3 plus 3, update these two values, increase I and decrease j. At this point we have, at this point we have 3 and 1. Absolute value of minus 3 is 3, absolute value of 1 is 1. Now we are coming into this else part. Okay, else part. Now we are checking that is array of I is not equal to previous, is 3 is not equal to minus, is minus 3, where this array of I minus 3, is minus 3 is not equal to minus 3? But it is equal, so we can't increase our count here. Okay, update the value of previous as a minus 3, update the I. So this is the dry run for this code. I hope you understand the question and the solution and the dry run as well. So thank you for watching.